Hello, so now we're going to continue with our chapter on trigonometry, and now we're going to look at solving trigonometric equations. So we're going to look at solving trigonometric equations. Now, the first thing before we even look at what we're supposed to cover today, when covering trigonometric equations, usually, how can I say, there is usually more than one answer. For example, let's say, let me give you an example. The cos of 90 is 0, but also the cos of 270 is also 0, and there are also very many other numbers whose cos is still 0. So what am I trying to say? So that's why when you give yourself very many trigonometric equations, usually you're given a range because literally the values keep going. So maybe they can say the value of solve maybe this equation, but the value of theta is between 0 and maybe 360. So they limit you. So this is just, I'm trying to tell you that usually it's more than one answer when you're solving trigonometric equations. So that's why they give you a range. Now let's look at what we're supposed to cover. So we're saying in solving trigonometric equations, we subdivide a circle into 4 equal parts known as quadrants. So we get a circle, divide it into 4. These are the quadrants, each being equal to 90 degrees. So we're going to see how we apply this. We label this 0, 90, 180, 270, and 360. So we're going to see how we apply this. Now we measure positive angles anti-clockwise. So that's why you see this thing is 0. It's going in an anti-clockwise form. For us to measure any positive angles, we are going to measure them like this. Then to measure negative angles, for example, if this is another, so we are going to actually be drawing this circle a lot in solving this equation. So this is 0, 90, 180, 270, 360. So you see we are labeling them anti-clockwise because we've said anti-clockwise positive angles. Then clockwise is for negative angles. So if we go like this, we're going for negative angles. If we're going the clockwise. Okay, so now let's look at something here. Now we are going to look at something about this quadrant. So before I even go further, we said we're going to be doing this quadrant almost at the end of every question. So this is 0, 90, 180, 270, and 360. So each of these quadrants, we're going to see what's the meaning of this quadrant. Now we are going to assume here a scale where this is the x-axis and this is the y-axis. Then I label this 1, 2, 3. I label this 1, 2, 3 positives. Then it's -1, -2, -3, -4, sorry, it's -1, -2, -3. Now this quadrant, this circle here, we assume that it was drawn on something like on an axis, like on axis y and x, something like this. So that's why this triangle is drawn. Now you see every triangle in this quadrant. We are going to assume a triangle with so this is 3 and this is 3, because this is a 3, this is also 3. Now that same triangle, we can draw it here with the same size, but now this is -3. Okay, then now we have the same triangle, but in the different quadrants. This will be -3, this will be -3. Then we will have the same triangle here. It's -3 and this is 3. We can draw the triangle here and find the hypotenuse. So this is 3, this is 3, and this is maybe C. So this is AB. So A squared plus B squared is equals to C squared. This is 3 squared plus 3 squared is equals to C squared. This is 9 plus 9 is equals to C squared. So C is root of 19. So the hypotenuse everywhere is going to be root of 19. Now let me explain what I'm saying from here. And the angle is the same, theta. The angle is the same, theta, theta. So now in each of these I'm going to do. Now the significance of this is going to come as at the end. You don't even have to remember this. I just want to explain something. So here we have, this is 3. This is 3 positive. This is root of 18. This is -3. This is the negative direction. And the hypotenuse everywhere is the same. It's positive, root of 18. This is root of 18. This is -3. This is +3. This is -3. So we have this. Now, so when you look at this, here, this is theta. The adjacent is positive. The opposite is positive. The hypotenuse is positive. So in this quadrant, everything is positive, like tan, the tan of theta, the cos, the sine, everything is positive. So that's why for here everything is positive. So we're going to see all are positive. That's why you put A. But here you see there's a negative here. So when you compute maybe here you'll find tan, cos, and sine are positive. When you go here you realize only sine is positive. When you go here you realize only tan is positive. The rest are negative. When you go here you realize only cos is positive. So now what am I aiming at? The only thing you have to master, you don't even have to master what I've been talking about. You just have to know that in the first quadrant, all are positive. This is what this means. All are positive. And what do we mean by all? We mean sine, cos, and tan are positive. Then here is sine is positive, others are negative. T, tan positive, others are negative. C, this positive. Now, so the formula, how to easily remember this? You remember all students take coffee, and you write it in the anti-clockwise form. All students take coffee. So that is the mnemonic to help you remember. Now we are going to start solving real numbers. Now before we actually solve, I want to talk about something very small here. So now we've said all students take coffee. So that's what you should remember. Now every time we are solving and we reach on the part of solving, we are going to bring back this table, and let's now look at an example and you see how it applies. Okay, so now we started. So we're starting with these simple concepts. So solve for the following equations for 0 degrees. So like for theta between 0 degrees and 360, but this is theta being less than or equal to 0, or no, sorry, theta being greater or equal to 0, less or equal to 360 degrees. Now, no question is going to be asked for you to like solve it like this. It's just that most of the trigonometric equations are going to end in this format. So that's why we're starting from here. Now, if you have find the value of solve for theta in this. So here we're going to say, so we're going to say cos theta. I'll take, so this will be cos theta is equals to a half. And I'll say theta is going to be cos inverse of half. Then now I get my calculator and say that's the cos inverse of a half. I get 60 degrees. Now, the mistake you would make is for you to assume or to think that the only answer to this trigonometric equation is 60 degrees. No, that's not true. That's why I told you we always need to have our quadrant in question. And for this case, I'm drawing it, but for other numbers, I'll just be pasting the already drawn one. So I'm drawing our quadrant. I first start by saying this is 0, this is 90, this is 180, 270, and 360 degrees. Then I have to draw our triangle for the quadrants. So here this is this, and then this. So you can choose to add this, though with time we won't be adding this. So we have this, and I have here my angle. The angle is 60 from the question 60. This is 60, and this is 60. And we said all students take chemistry. Now from our question here, cos theta is equals to a half. You see cos is equals to a half. This is positive. So we have two options here where all are positive, including cos, and also where cos is positive. So how do we get that? After getting the quadrants, we want to get an answer from, we now say up to this, because this is a where all are positive, including cos, and here where cos is positive. Then now here we go like this up to this quadrant. So the first answer would be 60. So theta is 60, comma 60 degrees, comma 360 minus 60. So theta is equals to 60 degrees, comma 300 degrees. And when you try to substitute that here, it will, so when you try to say cos 60, it will be a half. When you also try to say cos 300, it will be a half still. So you see, you can even prove your answer after. Okay, so let's continue this now. So here we have 2 sine theta is equals to -1. So here what we'll say, sine theta is equals to -1/2. Now every time we have a negative, so we are going to get what is theta. sine inverse of negative a half. So for us, every time we find a negative, we'll first say consider theta is equals to sine inverse of a half. Like we first consider for it to be like a positive. So here we have theta will be sine inverse of half. So this is 30. Then I will get our final answer by we draw the quadrants. We draw this, and now we can just, we don't have to draw like a full triangle, we can just draw this and then draw this. Then we say this is 30, this is 30, this is 30, and this is 30. Then we label this is 0, 90, this is 0, 90, 180, 270, 360. Now one thing you should note is these angles keep going. You can say 360 plus 90. That's if the question wanted beyond 360. You can keep adding. So here now we have 360 degrees. Okay. So now we have this. Then now, but here we write all students take coffee. So we have all students take coffee. All are positive. But for this case, we have sine is equals to negative half. So this is not true. Here sine is positive. We don't want sine to be positive. We want where sine is negative. I don't know if that makes sense. So these are the quadrants where sine is negative. Here T, only tan is positive, others are negative. C, only cos is positive, others are negative. So these are the two quadrants we want where sine is negative, because you have sine theta is equals to negative a half. So now when we have that, we now say, okay, where we go up to the quadrant we want, then we again go up to this quadrant we want. So what is theta? Theta is going to be, here we have it's here 180 plus 30, 180 plus 30, comma, to comma 360 minus 30. 360 minus 30. So we get theta as 180 plus 30, that is 210. This is 210, then 360. So we then 360 minus 30. This is going to be 330. So those are the two answers for that question. Now, as I told you, you can always try, and don't never forget to put the degrees. You can try to substitute them here. It will actually give you the answer. Then now we have this. So now for this, we'll say tan theta is going to be 1 out of root of 3. This is already positive, so we don't even have to consider. We just say theta is going to be tan inverse of this. So we can put it into our calculator. What is theta? Theta is going to be, what is theta? Theta is going to be tan inverse of, you can write it in the calculator like that, root of 3. The answer is 30. But remember, I told you we don't just take the answer to be 30. We actually come and draw the quadrant. We draw the quadrant. We have this. And I said going forward, we won't be drawing the full triangles, but hope now you know that this should have actually drawn the triangle, but we don't want to make it as crowded as that. So we come here and put 30. This is 30. This is 30. This is 30. Then we put all students take coffee, or all students take chemistry, whichever way you want to get. This is 90, 180, 270. You draw in, as we do numbers involving as you do trigonometric equation, you do this a lot until you eventually master it. So now, but here we have tan is equals to 1 out of root 3, which is positive. So here tan is positive, and here tan. So we look for where is tan positive. Here it's positive because all are positive, and here. Then let me try to change color because I don't want to make this so crowded. So the first thing we go up to here, then we go up to this region. So what is theta? Theta is going to be 30. That's the first 30 degrees. The second will be 180 degrees plus 30 degrees. So what is theta? Theta is going to be 30 degrees, comma 210 degrees. And when you try to substitute this into the equation, it actually fulfills the equation. So that shows we have our answer. So with these trigonometric equations, you can actually always prove, just like any other equations in mathematics, you can always prove to see if your answer is right or wrong. But just never forget this quadrant, because it's very important to help us find the answers. And I told you this 360, but it can keep going. And at the end, we shall see an example with negative angles, because here you see the question is saying between 0 and 360. But the question can even ask for negative angles, maybe between negative 360 to positive 360, but there the angles would be so many, and yet these numbers are not given so many marks. So it's usually either they can say between negative 180 to positive 180, but I told you the trick is positive angles measure in an anti-clockwise way, negative angles we measure them in a clockwise way. So we're going to see how we measure negative angles when needed. Okay, so let's now look at a few other numbers. All right, now we're going to start solving a few equations. So now here the question says solve this equation, and the angles we are going to take between 0, because I told you we always between 0 360 degrees. So now we have this. So you can see this resembles a quadratic equation. And now let me note something. When you see something like sine, this is the same as sine theta squared. It's just that this going in, it becomes sine squared theta. I don't know if that makes sense. So if someone writes something like sine cubed theta, this is the same as sine theta like cubed, but when the 3 enters it goes just to 1. Okay, hope that makes sense. So now how we solve this, usually let sine theta be maybe x. So you say this is 6x squared plus x minus 1 is equals to 0. This is a standard quadratic equation, and you choose any favorable method because there's usually a mark for solving the quadratic equation. Now this being our first number, maybe I can solve this, but ideally, okay, but let me use the quadratic formula. X is equals to negative b plus or minus b squared, and this is usually, if you don't have time, once you write this, then you now substitute negative 1 plus or minus, this is square root 1 squared minus 4 into 6 into negative 1 out of 2 into this. So x is equals to a third and x is equals to negative a half. So we've solved this. So you could have used any method. Now we're going to start with this one. So I'm going to say consider x is equals to a third. We are starting with 1. So what does that mean? Sine theta is equals to a third. So we'll say what is theta? Theta is going to be sine inverse of a third. So you get your calculator and say what is the sine inverse of a third? The sine inverse of a third is 19.47122. It continues like 30 on our calculator. That's the answer you get. But you round it up to 2 decimal places. So we'll say theta is equals to 19.47 degrees. Then now we can draw our quadrant. So we draw this. We draw this. This is 0, 90, 180, 270, 360 degrees. Then we draw this, as we said, draw this. Thus you have to get used to it. Then here you can label this is 19.47, 19.47, even here 19.47 and 19.47. Then we say all students take chemistry. In our question, sine theta is positive. So we look for the quadrants where sine theta is positive. Here all are positive, including sine theta, and here is sine is positive. So now these are the two quadrants we need. So then we now see where do we need? We need up to this. We just start from 0, then you go to where the line in that quadrant. So here we have this. So what is theta? Theta is 1, theta is 19.47 degrees, comma, theta is also 180 minus 19.47. So theta is 19.47 degrees, comma, 160.53 degrees. Now let's come and continue. When x is equals to negative a half. So when x is equals to negative a half, what does that mean? Sine theta is also negative a half. So here we'll come and say theta is equals to sine inverse of negative a half. Now, some people may want to just put this into the calculator and say, what is the sine inverse of negative a half? You get negative 30. and that's not going to help you find the answers we need. Yet the question wants positive answer. So that's why usually when I find a negative, you say consider theta is equals to sine inverse of a half. Now here you're trying to tell the person, the examiner, you're trying to show that this is not what you actually want. You don't want the sine inverse of a half, but you're just considering it for now. Then you go to your calculator and say, what is the sine inverse of a half? It is 30. Sorry, it is 30. But that is not the final answer we need. Now we draw a quadrant. That quadrant is what is going to help us find the answer we need. So we do the quadrant. This is our quadrant. We take this. This is 0. This is 90, 180, 270, 360. So this is 30 degrees. This is 30 degrees from what we get as theta. This is 30 degrees. And this is 30 degrees. Then we now say all students take chemistry. But now in this question, sine theta is equals to negative a half, and all are positive, so we don't want that because we want it to be negative. Here sine is positive, but we want negative. So here tan is positive, others are negative. So these are the two regions we want. Then you come and say, start from here, because you want a positive angle, you go anti-clockwise. That's the first one. Second one will be you come up to this. So what is theta? Theta is going to be, the first one is going to be 180 plus 30, comma 360 minus 30. So we have theta is equals to 210, comma 330 degrees. Never forget to put the degrees. Now this, even if you just try to put it here, let me show you. If you say what is sine of 210, it's negative a half. Like if you just try to substitute it here, it already shows you. Then now after this, you're supposed to come and quote all your answers. So you say theta is equals to 19.47 degrees, comma, you can usually, they want you to write them in like ascending order. This, comma, 10 degrees, comma, 330 degrees. So you see, we have this. So these are the answers. Now you can actually try and substitute these answers here and see if you're correct. Now let me show you how. Remember, the question says this is 6 sine squared theta plus sine theta minus 1 is equals to 0. So remember, we say this is 6 into sine theta squared plus sine theta minus 1. So I'm just showing you that when if you to put sine theta, you put sine theta, then you like square it outside, and you will see it will be all those values are going to fulfill this equation. Okay, now let's look at another number. So now here we have this. We have 2 cos squared plus sine theta is equals to 1. So this now takes us back to remember what was the Pythagoras theorem, the identity derived from the Pythagoras theorem, which was cos squared theta plus sine squared theta is equals to 1. So if you make cos squared the subject, will have cos squared theta is equals to 1 minus sine squared theta. So here we have 2 into 1 minus sine squared theta plus sine theta is equals to 1. So we have 2 minus 2 sine squared theta plus sine theta is equals to 1. So here we form our quadratic, and I think I can take all these the other side. So I have 2 sine squared theta minus sine theta. This is 1 minus 2 minus 1 is equals to 0. Then I calculate sine theta be a, for example. I can let it be a. And so I have 2a squared minus a minus 1 is equals to 0. Now I told you I'm not going to be solving these quadratic equations, but I expect you to know that you're supposed to actually solve because there's a mark for the working. Don't just quote the values the way I'm quoting them. So you have to come and say a is equals to negative half or a is equals to 1. So, but just know there's a working is required for you to get the mark for this equation. Otherwise, you will miss the mark. So maybe let's start with a is this. What does that mean? Sine theta is equals to negative half. Same thing we did the other side. So here I will say theta is equals to sine inverse of negative a half. But I've told you, you don't just put this into the calculator because you will not get the answers you need. So what do you say? You say consider theta being equals to sine inverse of a half, such that you come to your calculator and say theta is equals to sine inverse of a half. So what do I have? So what do I have? I have it is 30. Then I draw our quadrant again. The work is looking somehow disorganized, but I hope you're following. So we have this, and like always I said, we won't be drawing the cut triangle in every quadrant, but that is just a represent. So you have 0, then 90, then 180, then 270, then 360. This is degrees. You don't forget to write the units. Now here we have 30 at every point, 30, even here 30, even here 30, even here 30. Then now we write all students take coffee. All students take chemistry. But now here we have sine theta is equals to negative a half. So here sine is negative, meaning we look for a quadrant where sine is negative. Here all are positive, including sine, so we don't want this. Here sine is positive, so we don't want this because we want sine to be negative. Here tan is negative, but all the others are, tan is positive, all the others are negative. So sine is also negative. Here cos is positive, all the others are negative. So we also want this. So these are the two quadrants we need. So I'm just changing the color such that for now, because we're just starting for you to follow. So here we come up to this quadrant, since it was one of the desired quadrants, then we come this one of the desired quadrants. What is theta? So theta is going to be 180 plus 30, comma 360 minus 30. So theta will be 210 degrees and 330 degrees. So, and as I told you, you can prove these. You can try to put them into this, and you will find. So when you say sine 210, it will be negative half. Sine 330 to be negative half. Okay. Now let's continue and say, how about when a is 1? Now this is somehow tricky. I'm going to talk about it now. When a is 1, what does that mean? Sine theta is equals to 1. So I come and say theta is going to be sine inverse of 1. So what is theta? So this is going to be sine inverse of 1, which is 90. You see? Now, what makes this tricky, as I was saying, see, now imagine you draw your quadrant like this. This is 0. This is 90. This is 180. This is 270. This is 360. Now, imagine you've drawn your quadrant like this, expecting to do the number normally. This is maybe, but now this is already 90, which is like here. It's at it's like it's like at the boundary of a quadrant. So now once like your answer is maybe 90, that's maybe if the sine inverse of 1, or if anything, like when you get its cos inverse or sine inverse is giving you something like 90, just know the quadrant is not going to work. So what are we going to do for those cases? So if you watch one of our earlier videos, I drew for us a graphs of theta and sine theta, of theta and cos theta. Now we're going to do the graph of theta and sine theta. Now for here, I'm just rewriting it because, but ideally you're just supposed to be you draw and then you, but now let me just do it for now. So the question has already given us boundary between 0 and 360. So I can say 0, then I put 90, then I put 180, then I put 270, and I put 360. I can even stop here. So now this is sine theta. Now go into the calculator and say what is the sine of 0. Sine of 0 is 0. What is the sine of 90? Sine of 90 is 1. What is the sine of 180? The sine of 180 is 0. What is the sine of 270? Sine of 270 is negative 1. Then what is the sine of 360? Sine of 360 is 0. So after that, I can now draw my axis here. So actually, even if someone went into negatives, just that I didn't want to take so much time. So we have this. Now this axis, which would have been the x-axis, is theta. This axis, which would have been the axis, is sine theta. So now I can put here my units 90. This is 0, 90. Then 180. Then 270. 360. Here there's negative 90. If we had time, we would have actually plotted all of them, but because of time, then this is negative 270 and negative 1 and 1. I spent actually a good number of minutes explaining this graph in the first, well, I think the first or the second video on trigonometry. So here 0 is 0. So I'm plotting the point here 0, 0. 90 is 1. 180 is 0. 270 is negative 1. 360 is 0. So I can now draw that graph. Let's draw the graph and see. So it's like this. So now for this case, the question wants sine of 1. So I just look for 1. I look for 1, like here I draw like a line on 1. And I look for what things. Okay, let me now show you with this. Now if you continue here, you're going to find a sine of negative 90 is going to be negative 1. A sine of negative 180 will be 0. Then the sine of negative 270 will be here. So this graph, when it continues, it actually looks like this. I didn't draw the negatives because the question had already given me a range between 0, theta, and 360. You see, this was the range the question gave me. That's why I didn't know the negatives, but to show you what I'm trying to say, I've added the negatives. Now, so the question here is saying sine theta is 1 here. So I've drawn like a line at 1. Now the first thing I have here is 90. That's why you see theta is 90. But I also have 1 here, like when I extrapolate, you see even negative 270. So even negative 270 is the correct answer for sine theta is equals to 1. Actually, when you say sine of negative 270, it's actually 1. But here, what doesn't make it a correct answer is because of the range. This range is limited, has to be between 0. I don't know if this makes sense. So that's how we determine if we have something like sine inverse of 1 or sine inverse of or cos inverse of 1. So that's how we do it. So, but with more practice, it will make sense. So here, the only answer we have is 90 within the range, but even negative 270 is an answer, but it's not in the range. So we come and now quote all our answers here at the end. We can start with 90 degrees and we go to 10 degrees and we go to 30 degrees. And as I told you, you can prove, you can come and say 2 cos squared theta plus sine theta should be 1. Then you try knowing that 2 cos theta is the same as 2 cos theta this squared plus sine theta being 1. So you can try and say maybe, let me say, what is the cos of 90 times 2? The cos of 90 is 0 squared times 2. So it eventually the answer is the same as you're going to see. So